In this series on A Level Maths, we've done a lot of the, sort of admin type stuff where it's about mathematical language and arguments and structures, rather than getting into some nice problems and learning it. There's some more mathematical structure stuff they want you to know, mathematical arguments, things, but we'll look at actual topics now, and then we'll pick up those things as we go through the syllabus. Today's video is on proof. We're going to do a proof by deduction example and a disproof by counterexample. Right, let's get into that. So the first question is, can you prove that n squared minus 16n plus 70 is positive for all n in the real, shall we say? Right, I'm going to, and proof by deduction we're going to use here. Proof by deduction is using what we know to derive other facts about the thing. So all we know is this, so we're going to have to work with this. What can we do with expressions like this? We can complete the square of this expression. That's what we're going to do. So we put n minus 8 in the brackets and square it, and that would give us, and we still have our plus 70, that would give us n squared minus 16n plus 64, and then we have our plus 70, but we don't want our plus 64 in the end, so we take that off. And now this is equal to n minus 8 squared plus 6. Okay, and seeing as n minus 8 is squared, well, that's positive, and 6 is clearly positive for all n. It's a constant function, so if we have a function f of n equals 6, we can plug in whatever value of n. It's always equal to 6 by definition. So this is all positive, and we'd write some sort of qualifying statement saying maybe, since both the terms are positive and we're adding two positive terms together, n squared minus 16n plus 70 must be positive, and that's all you have to do for that one. So now we're doing another example, and this is a disproof by counterexample. In an exam you might just be told prove or disprove this, then you'll have to think yourself about whether this is true or not. So is true is prime for all n, and that's integers n. Okay. Well, I think we'll just look at natural numbers. Right. What I'm going to do here is, well, I know that I've got to disprove this, and I'm going to take, so all I have to do is disprove this is give one example where this is not true. So when you're proving something, you can't give one example because it has to be true for all of them. But if I'm saying it's true for all of them, if I can show that it's true, that it's not true for at least one, well, that statement's false then. Okay, so I'm going to take n equal to 29, and the reason I've done this is because you can see this term on the end is 29. If we put 29 into these n terms, we'll be able to factorise out 29, and when we can factor something out, well, it's clearly not a prime, but we'll see that more clearly in a second. So taking n as 29 leads to this expression being equal to 29 squared plus 29 plus 29, and if we factorise out the 29, we get 29 multiplied by 29 plus 1, and that's equal to 29 multiplied by 31. Well, and remember that's equal to n squared plus n plus 29 when n is equal to 29. And if n squared plus n plus 29 is equal to two integers that are not n squared plus n plus 29 or 1, well then it's not prime by definition. We found two factors of this which are not 1 in itself, so therefore it's not prime. So we've disproved this result, and you'd have to write again, like most proofs, some sort of qualifying statement, explain your logic. You can't just do a load of math. But that is it for that example, and that concludes the video. In the next video we'll look at proof by contradiction and proof by exhaustion. That's the next A level video anyway. But for now that's it. If you do find this useful, please let me know in the comments, and like and subscribe, and I hope to see you in the next one.